Okay, in this video, I'm going to give you what we call a brief review of some of the basic things that you're going to need to know in order to do some of the problems in Unit 4B, the power of compounding. So make sure you watch this video first before you watch the other video on the power of compounding, Unit 4B. Okay, here we're going to look at some of the basics of powers. Here, a number raised to the nth power is that number multiplied by itself n times. And here, your n is going to be the exponent. So, like for example, 2 to the first power will be 2. 2 squared is 2 times 2, which would be 4. 2 to the third, or 2 cubed, as we might say it, will be 2 times 2 times 2, which would be 8, and not 2 times 3. That exponent tells you how many times, in this case, 2 is going to be used as a factor. Now, number raised to the 0 power is defined to be 1. So, 2 to the 0 power is equal to 1. So here, any non-zero number to a power of 0 will always be equal to 1. Okay? And then, your negative powers are going to be reciprocals of the corresponding positive powers, like 5 to the negative 2 power. That will be 1 over 5 to the positive 2, which would be 1 over 5 times 5, or 1 over 25. Also, 2 to the negative third power will be 1 over 2 to the positive 3 power. So if we figure this out, it'll be 1 over 2 times 2 times 2 for 2 to the third. And if you multiply those 2's out, you'll get 8. So it'll be 1 over 8. Okay, next is going to be the power rules for exponents. Usually, we're going to be dealing with the product rule, the quotient rule, and the power rule. This one deals with the product rule for exponents. If you multiply powers of the same number, you're going to add the exponents. So here, a to the n times a to the m, that's equal to a to the n times n plus m. You add your exponents. So here, 2 to the third multiplied by 2 to the second. The numbers, or the base, they're both the same. We bring over that base and add your exponents. So we add 3 and 2 together, you're going to get 5. So it'll be 2 to the 5th power, which will end up being 32. And then to divide powers of the same number, you're going to subtract the exponent. So here, a to the n divided by a to the m, we're dividing powers where the bases are the same. We bring over the base, but we subtract the top minus the bottom, n minus m. So up here in this example here, 5 to the third divided by 5 to the second. Here, the bases are the same. We still have the base of 5. We bring over the 5. We subtract 3 minus 2 to get 5 to the 1, or just simply 5. And then, when a power is raised to another power, we multiply the exponents. We call that raising a power to a power. In this case, a to the n times m. A to the n raised to the m, we multiply the n and the m together, those exponents. So it'll be a to the n times m. Like 2 to the second raised to the third. We'll take that 2, bring that over, multiply those exponents 2 times 3, which will be 6. So it'll be 2 to the 6, or 64. And now let's look at roots here. Finding the root is the reverse of raising a number to a power. Second roots, or square roots, are written with a number underneath the root symbol, or sometimes we call it the radical. More generally, we indicate an nth root by writing the number under the symbol, like this right here. That n, and then you got the root symbol. For example, this is a square root of 4. You want to find out what number times itself will give you 4. It will have to be 2. And that's because 2 squared will give you 4. This one would be the cube root of 27. That means what number to the third power would give you 27? And it has to be 3. Because 3 cubed, or 3 times 3 times 3, is 27. And then we got the fourth root of 16. You have to think of this. What number to the fourth power will give you 16? Has to be 2. Because 2 times 2 times 2 times 2 does give you 16. And then the sixth root of a million, that will be 10. Because you have to think of what number to the sixth power will give you 1 million. And it has to be 10. And then you got roots of fractional powers here. The nth root of a number is the same as the number raised to the 1 over n power. That is, if I have x to the 1 over n, that would be the nth root of x. So for 64 to the 1/3 power, that's saying the cube root of 64, which will be 4. Or 1 million to the 1/6 power would be the sixth root of a million, which would be 10. Okay, now we're going to look at some of these examples that deal with powers and roots. Like right here, example 13. If I have 9 to the second power, and I want to evaluate that, here I can write this as simply 9 times 9. And that will be 81. Because 9 is going to be, that 2 tells me 9 is going to be used as a factor 2 times. Now, for 8 to the negative 2 power, for negative exponents, I always write that as 1 over the base of 8 raised to the positive 2 power. That's how we always write a negative exponent. 1 over that base to the positive power. So 1 over 8 squared, well, that's 1 over, I can write 8 to the second as 8 times 8, which is 64. So 1 over 64 would be what 8 to the negative 2 power will be. Okay. Let's look at some more examples here. A couple of more. Like in example 15, we got 144 to the 1/2 power. Well, if I write this as this, that 2 would be the index for the root, then 144 would be to the first power. And it'll simply be 144. But here, we don't usually write the 2 with that radical because it's understood to be there. So I can write that as the square root of 144. And to do the square root of 144 on the calculator, you do second x squared. Second and x squared will give you the square root and then 144. And then hit enter. And that will give you the 12. So 144 to the 1/2 power would be 12. And then for this one, 8 to the negative 1/3 power, this will be 1 over the 8 to the positive 1/3. Now that 8 to the 1/3, I'm going to show you this. You can type this in the calculator. If you press the number 8 and then press this half key up here, 1/3 you can do 1 divided by 3. And then hit enter. That will give you 8 to the 1/3, which is 2. So 8 to the negative 1/3 would be 1/2. Okay. Okay, now let's look at some more review here. This is going to be for the basic rules of algebra. Okay. Basic rules of algebra. Okay. So here in algebra, you're going to be solving equations with some variable. Here's some reviews here. The four basic rules is going to be this. Number one, you can interchange the left and right sides of an equation. That is, if you got x equal to y, it is true for also y is equal to x. And then second, you can add or subtract the same quantity or the same number on both sides of an equation. Number three, you can multiply or divide both sides of an equation by the same quantity, as long as you do not multiply or divide by zero. Because the division by zero, by the way, is undefined. Number four, you can raise both sides of an equation to the same power or take the same root on both sides, which is equivalent to raising both sides to the same fractional power. We're going to do one of those examples shortly, okay? And these are just a few examples here that they give you. We're going to do some here in this particular video. Like this one. We'll start with this one. Z minus 10 is equal to 29. And here I want to solve this equation for Z. Here I'm subtracting 10, so we need to do the opposite of subtracting 10, which will be to add 10 to both sides of this equation. So that means I'm going to have Z is equal to 29 plus 10, which is 39. So Z is equal to 39. That will be the solution to that linear equation. Now, you can check by doing 39 minus 10. That would give you 29. Okay. Example 18 is 4x is equal to 40. Well, we want to solve for x. That means x is being multiplied by 4. So I need to divide both sides of this equation by 4 to get x by itself. Because these 4's divide out, you'll be left with x equal to 40 divided by 4. That'd be 10. And it does say solve and check. So for the check here, take the original equation and replace the x with 10. So 4 times 4, would that be equal to 40? And if I multiply 4 times 10, it does. So 40 equal to 40 is the, 40 equal 40 check, so that means x equals 10 is the solution to that linear equation. Okay. In this example, 19, we got 5x minus 2 is equal to 23. And I want to get x by itself. Here we got a two-step equation here that we want to solve for x. So the first thing I need to do here is get rid of the minus 2. I'm subtracting 2, so I need to add 2 to both sides. So now you got 5x is equal to 25. And then to get the x by itself, I'm multiplying it by 5, so I need to divide both sides by 5. So here x is equal to 5. That's my proposed solution. However, they did say do the check. So I'll take the original equation and replace the x with that 5. So it'll be 5 times 5 minus 2. That should equal to 23. And if I multiply 5 times 5, that would be 25. Minus 2 equal to 23. 25 minus 2 would be 23. So that checks. So x equals 5 is the solution to that linear equation. Okay. Now, let's say we had an equation with the variables on both sides, like 8y plus 2 equal 7y minus 3. And I want to solve this equation. Well, first of all, I want to collect all the variables on one side of the equation. And it will be easier to move the variable that has the smallest coefficient, that's the number in front of the variable, over to the opposite side. It'll be easier to move the 7y over to where the 8y is. And I'm going to write this out. I'm going to do that by subtracting 7y on both sides. So here I'm subtracting 7y on this side as well. And you're going to see when I do 8y minus 7y, that's going to give me 1y, or just a y, plus 2, equal to, these 7y's are gone, I'm left with negative 3. And then to get the y by itself, I'm adding 2, so I need to subtract 2 on both sides. So here y is equal to, now when you do negative 3 minus 2, you're going to end up with negative 5. Okay. Now, in this example, we're going to be using the 4 basic rules of algebra to solve this equation. 8x minus 22 equals 64x plus 6x. In this case, we want to get all the variables on one side of this equation. Okay? Let's move the 6x over to where the 8x is. And you can do the shortcut way by just doing this, subtracting 6x on both sides. And notice I have the x's underneath one another. They're like terms here. So 8x minus 6x will be 2x, then minus 22 is equal to, you're left with 64 because these 6x's are gone. And now to get the 2x by itself, I'm subtracting 22, so I need to add 22 on both sides. So this will be 6x is equal to, 2x is equal to 86. And now, to solve for x, I'm multiplying by 2, so I need to divide both sides by 2. So 86 divided by 2 will be 43. So x equals 43 will be the solution to that linear equation. Okay. Now, here we're going to solve for x. Notice we got x squared, or x to the second power, is equal to 144. Now, I need to get rid of that exponent of 2. Now, let's think about this for a moment. What is the reciprocal of 2? It's reciprocal 1 over 2. Just like 2 over 1. Take the reciprocal, flip it, you'll get 1/2. So, what I'm going to do here is raise both sides of this equation to the 1/2 power. So here, x to the 2, x squared raised to the 1/2, that means I can multiply the exponents. 2 times a half will be 1 whole. So I'm going to have x to the 1, or just x. Now that 144 to the 1/2, if I do 144, hat key, and then type in 1 divided by 2 for my exponent, I'm going to get 12. So here, this will be x equals 12. Now, there is another way you could do this. If you are familiar with the fact that the square and the square root are inverses, you can take the square root on both sides. Okay? And I do need to mention here, is not just 12, it's this, plus or minus 12. Because when you take the square root on both sides here, you're going to have a positive and a negative number. The square root of 144 will be a positive 12. The square root of 144 will also be negative 12, because negative 12 squared will also give you 144 as an answer. So here, when you take the square root on both sides, you're always going to have two answers. Or raise it to the 1/2 power, you'll have two answers. X equal to 12 and x equal to negative 12. Okay, now this last example is somewhat like that. X minus 7 quantity squared is equal to 36. Here we're squaring the x minus 7. So what would be the opposite of squaring something? And that will be to take the square root on both sides. And when you take the square root on both sides, you want to include this symbol, plus or minus, because you're going to have two answers here. The square root of x minus 7, and that squared will be x minus 7. The square root of 36, what number times itself will give you 36? It'll be 6. So here we're going to have x minus 7 equaling the plus or minus 6. In this case, we got two equations here. One equation will be x minus 7 will be equal to positive 6, or x minus 7 equal to negative 6. And each equation we're going to solve for x here. So for the x minus 7 equal to 6, here if you add 7, you're going to get x is equal to 13. Or for the x minus 7 equal to negative 6, here if you add 7 here, you're going to get x is equal to 1. Okay? So my two solutions are x equal 13 or x is equal to 1. Okay? So this is just a brief review of the common basic rules of algebra and for exponents and roots that you're going to need to be familiar with in order to do section 4B.